How air traffic control works. Every hour during peak air travel times, nearly 5,000 airplanes grace the skies of the United States. Think about it. That means approximately 50,000 aircraft operate in our skies each day. Find out the sophisticated web of humans, air traffic controllers, tools, processes, and technology that keep air travel safe, ensuring, for example, that aircraft don't collide with each other and that air traffic moves seamlessly into and out of an airport or across the country. Watch now. Welcome back, folks, to another edition of Sweetie Kiwi. How are you doing today? I hope you are doing fantastic. I'm doing marvelous, if you were to ask me. And if you are doing as great as I am, go grab a cup of coffee or tea or vodka and let's roll. I want to talk to you today about how air traffic control works. Now, airspace and air traffic control. So the task of ensuring safe operations and commercial and private aircraft falls on air traffic controllers. They must coordinate the movements of thousands of aircrafts, keep them at safe distances from each other, direct them during takeoff and landing from airports, direct them around bad weather, and ensure that traffic flows smoothly with minimal delays. When you think about it, when you think about air traffic control, the image of men and women in the tower of an airport probably comes to mind. Nonetheless, the air traffic control system is much more complex than that. In this video, I want to really show you how air traffic control works in the United States. So, the United States airspace is divided into 21 zones. They're called centers, and each zone is divided into sectors. So you have zone and sectors. Also within each zone are portions of airspace about 50 miles in diameter called TRACON. TRACON stands for Terminal Radar Approach Control Airspace. TRACON airspaces. So 50-mile radius. 50 miles. So we have 50 miles to about 80.5 kilometers. Within each TRACON airspace are a number of airports, each of which has its own airspace with a 5-mile, 8-kilometer radius. So the air traffic control system, which is run by the Federal Aviation Administration, the FAA, has been designed around this airspace divisions. The air traffic control systems divisions are, so you have the Air Traffic Control System Command Center, that's the ATC-SCC. This organization, this department oversees all air traffic control. It also manages air traffic control within centers where there are problems. I'm talking here about bad weather, traffic overloads, inoperative runways. The second category is Air Route Traffic Control Centers, the RCC. There is one RCC for each center. Each RCC manages traffic within all sectors of its center except for TRACON airspace and local airport airspace. Let's talk about Terminal Radar Approach Control. TRACON handles departing and approaching aircraft within its space. Air Traffic Control Tower, the ATCT. An ATCT is located at every airport. So every airport you go to, they have an ATCT. And especially when the airport has regularly scheduled flights. So towers handle all takeoff, landing, and ground traffic. Then you have the Flight Service Station. The FSS provides information about the weather, the route, the terrain, the flight plan for private pilots flying into and out of small airports and rural areas. It assists pilots in emergencies and coordinates search and rescue operations for missing or overdue aircraft. So the bottom line here is that the movement of aircrafts through the various airspace divisions is much like players moving through a zone defense that a basketball or football team might use. Think about it that way. Think about it with a sport metaphor. As an aircraft travels through a given airspace division, it is monitored by the one or more air traffic controllers responsible for that division. The controllers monitor this plane and give instructions to the pilot. As the plane leaves that airspace division and enters another, the air traffic controller passes it off to the controllers responsible for the new airspace division. It's like I'm driving and I go from one country to the other, if I'm driving from, say, from one state to the other, or from the United States to Canada, once I'm in Canada, the monitoring, the tracking is just passed on to the Canadian authorities, right? So some pilots of small aircraft fly by vision only. This is called the VFR, Visual Flight Rules. These pilots are not required by the FAA to file flight plans, and except for FSS and local towers, they're not serviced by the mainstream air traffic control systems. Pilots of large commercial flights use instruments to fly instrument flight rules, or IFR, so they can fly in all sorts of weather. They must file flight plans and are serviced by the mainstream air traffic control system. Now let's talk about the flight profile. Let's just talk about how a commercial airline prepares the flight before it takes off. I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Kiwi. We are still having a conversation here around how air traffic control works, and I want to show you right now, as we're showing on the screen here. We have a nice illustration from how stuff works, and we have the pre-flight, the takeoff, the departure, en route, descent, and approach and landing. Suppose you're flying across the United States, perhaps from Chicago to San Francisco, or from New York to LA. So your flight, like every other commercial airline flight, follows a typical profile. So you have something called a pre-flight. So this portion of the flight starts on the ground and includes flight checks, pushback from the gate, and taxi to the runway. Next, you have takeoff. So the pilot will power up the aircraft and speeds down the runway. Next, you have departure. So the plane will start lifting off the ground and climbing to a cruising altitude. Then you have en route. The aircraft during this phase travels through one or more center airspaces and nears the destination airport. Next, you have descent. The pilot during this phase descends and maneuvers the aircraft to the destination airport. Approach. The pilot will align the aircraft with the designated landing runway. And again, all these things is monitored and instructed by the air traffic controllers. And then finally, you have landing. So during this phase, this is where everybody's relieved. Every passenger is relieved. People start praying, whatever. The aircraft during landing will land on the designated runway, taxis to destination gate, and park at the terminal. Let's talk about pre-flight here, because it's very important to understand what's really happening. Pre-flight, while you prepare for your flight by checking your bags and walking to the gate, your pilot inspects your plane and files a flight plan with the tower. So all IFR pilots must file a flight plan with at least 30 minutes prior to pushing back from the gate. So your pilot will review the weather along with the intended route, maps the route, and flies and files the plan. So the flight plan includes the airline name and the flight number, the type of aircraft and equipment, intended airspeed and cruising altitude, the right of flights, so the departure airport, centers that will be crossed, and destination airport, and your pilot transmits this data to the tower. Here is what a typical flight progress strip might look like. So in the tower, a controller called a flight data person reviews the weather and flight plan information and enters the flight plan into the FAA host computer. The FAA has a huge database in which all flight plans must be entered into. The computer generates a flight progress strip that will be passed from controller to controller throughout your flights. So the flight progress strip contains all the necessary data for tracking your plane during its flight and is constantly updated. Once the flight plan has been approved, the flight data person gives clearance to your pilot. This is called clearance delivery, and then passes the strip to the ground controller in the tower. The ground controller is responsible for all ground traffic, which includes aircraft taxiing from the gates to takeoff runways, and from landing runways to the gates. So when the ground controller determines that it is safe, he or she will direct your pilot to push the plane back from the gate. Airline personnel operate the tugs that actually push the aircraft back and direct the plane out of the gate area. What happens is that as your plane taxis to the runway, the ground controller watches all of the airport's taxiways and uses ground radar to track all of the aircraft, especially useful in bad weather and foggy weather. And by doing that, he or she ensures that your plane does not cross an active runway or interfere with ground vehicles. The ground controller talks with your pilot by radio and gives him or her instructions, such as which way to taxi and which runway to go to for takeoff. Once your plane, at that point, reaches the designated takeoff runway, the ground controller passes the strip to the local controller. Now, the local controller in the tower watches the skies above the airfield and uses surface radar to track aircraft. He or she is responsible for maintaining safe distances between planes as they take off. The local controller gives your pilot final clearance for takeoff when it is deemed safe and provides the new radio frequency for the departure controller. Once clearance is given, your pilot must decide if it is safe to take off, right? Because the decision there rests on the pilot. If it is safe, he or she accelerates the plane down the runway. As you leave the ground, the local controller hands your plane off electronically to the departure controller at the TRACON facilities that services your departure airport. But he or she still monitors the plane until it is 5 miles from the airport. Your pilot now talks with the departure controller. I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Q. We're also having a conversation today around how air traffic control works. And I was just talking to you before about pre-flight, the pre-flight phase. Let's now talk about the departure, en route, and descent phase, the various air traffic control facilities encountered by a plane during its flight. So once your plane takes off, your pilot activates a transponder device inside the aircraft. The transponder detects incoming radar signals and broadcasts an amplified, encoded radio signal in the direction of the detected radar wave. The transponder signals provide the controller with your aircraft flight number, altitude, airspeed, and destination. A blip representing the airplane appears on the controller's radar screen with this information beside it, so the controller can now follow your plane. An airplane's transporter transmits flight data to incoming radar signals. Now, the departure controller is located in the TRACON facility, which may have several airports within its airspace. Remember the 50-mile, 80-kilometer radius I was talking to you earlier about? So he or she uses radar to monitor the aircraft and must maintain safe distances between ascending aircraft. The departure controller gives instructions to your pilot, the heading, the speed, the rate of ascent, to follow regular ascent corridors through the TRACON airspace. The departure controller monitors your flight during ascent to the en route portion. When your plane leaves TRACON airspace, the departure controller passes your plane off to the center controller, the RTC controller. So every time your plane gets passed between controllers, an updated flight progress slip gets printed and distributed to the new controller. Remember, folks, that we're talking about the example here assumes that we are within the skies of the United States. This is not for international flights. So when I'm using acronyms like TRACON, RTC, this applies specifically to the United States. Let's talk now about en route and descent. So once your plane has left TRACON airspace, it enters a sector of the RTCC airspace where it is monitored by at least 2 air traffic controllers. So you have the radar associate controller, and then you have the radar controller. Those are 2 very key air traffic controllers. So the radar associate controller receives the flight plan information anywhere from 5 to 30 minutes prior to your plane entering that sector. The associate controller works with the radar controller in charge of that sector. Now, The radar controller is in charge of all air-to-ground communication, maintains safe separation of aircraft within the sector, and coordinates activities with other sectors and or centers. So the controllers must monitor the airspace at high altitude. Here I'm talking about 25,000 feet. So you're talking about 7,000 to 8,000 meters. And low altitude below 24,000 feet. The center controllers provide your pilot with updated weather and air traffic information. They also give directions and instructions to your pilot regarding such aspects as speed, altitude to maintain a safe separation between aircraft within the sector, and weather. So they monitor your plane until it leaves their sector. Then they pass it off to another sector's controller. Another controller called the radar handoff controller assists the radar and associate radar controllers during times of heavy traffic, watching the radar screen and helping to maintain smooth air traffic flow. So while you're just enjoying your movie, enjoying your snack, your meal, or the view outside the window, your plane gets passed from sector to sector to sector to sector and center to center to center to center. In each sector, center controllers radio instructions to the pilot. The path of your plane may have to be changed from the original flight plan to move around bad weather or avoid a congested sector. So your pilot may request a change in altitude to avoid or reduce turbulence. So this back and forth between pilots and center controllers continues until you are about 150 miles, 241 kilometers from LA or San Francisco, your destination. So at this point, the center controller directs our plane flying into LA or San Francisco to move from high altitudes to low altitudes and merges the descending aircraft into a single file line toward the airport. So the controller gives instruction to your pilots, such as changes in heading, speed, and altitude to place your plane in line with these other aircraft, right? Because your plane is not the only one heading to San Francisco or LA. So depending on traffic conditions, the controller may have to place your plane into a holding pattern, which is a standard route around each airport where you wait until the airport can handle your arrival. The controller continues to give directions and instructions to your pilot until your plane is within tracking airspace. I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Kiwi. I hope you are doing fantastic. We're still talking today about how air traffic control works. And if you love this kind of content and you love the clarity and quality of the content so far, please consider subscribing to our channel and turn on the notification bell. We surely appreciate that. Also, comment below if you have questions or you just want to share your experience with us. If you are air traffic controller yourself or have experience in the airline industry, we certainly would love some contributions, some feedback here, and also like this content and share. I want to talk to you now about approach and landing. Approach. When your descending plane is, say, 50 or 45 miles from the Los Angeles airport, it is within tracking airspace. An approach controller directs your pilots to adjust the aircraft's heading, speed, and altitude to line up and prepare it to land along standard approach corridors. Your pilot then aligns your plane with the runway. So when you are 10 miles, about 16 kilometers from the runway, the approach controller passes your plane off to the local controller in the airport tower. Let's talk about landing. The local controller in the airport tower checks the runways and the skies above the runways with binoculars and surface radar. Local and ground controllers are the only controllers licensed to use visual information in performing their duties. So when the local controller determines that it is safe, he or she gives your pilot clearance to land. The local controller also updates weather conditions for your pilot and monitors the spacing between your plane and other landing aircraft. Once you've landed, the local controller directs your plane to an exit taxiway, tells your pilot the new radio frequency for the ground controller, and passes your plane off to the ground controller. The ground controller at that point watches the runways and taxiways, and uses ground radar information to ensure that your taxiing aircraft does not cross active runways or interfere with ground vehicles. He or she directs your plane to the appropriate terminal gate. Ground personnel from the airline use hand signals to assist your pilot in parking the car at the gate. So you have basically heard, I've been using the word controller. We've had a lot of controllers: approach controllers, radar controllers, departure controller, center controller, ground controller, flight data person. This is a lot of controllers, right? So let's talk about the careers and concerns. What does it take to be an air traffic controller? To be a ground controller, you have to memorize the position of aircraft on the runways and taxiways with a single short glance. Local, TRACON, and RTC controllers must be able to think and visualize in 3 dimensions. All controllers must be able to gather information from what they hear, make decisions quickly, and know the geography of their own airspace, as well as that of others. They must be able to read and interpret symbols, as well as predict the whereabouts of aircraft from course headings and speeds, and they must be able to concentrate intensely. So there is a, if you want more information, you have to go to the FAA website, www.faa.gov, because all air traffic controllers at all levels are employed by the FAA. To become an air traffic controller, you must apply through the Federal Civil Service System and pass the written test that assesses your abilities to perform a controller's duty. Abstract reasoning and 3D spatial visualizations are tested on the exam, so applicants must have 3 years of work experience, a 4-year college degree, or some combination of the two. So if you are accepted into the training program, you will attend the FAA Academy in Oklahoma City, Oklahoma, for 7 months of training. While there, you will learn the air traffic control system, equipment, regulations, procedures, and about aircraft performance. You'll need to pass a final examination before you graduate. After graduation, you will accumulate work experience at various sites across the country, from airport towers to RTCs. You must be certified for various positions such as ground controller, associate radar controller, and radar handoff controller. You will be required to pass annual physical examinations, semi-annual performance examinations, and periodic drug screenings. Air traffic control positions are highly competitive jobs, and the controller workforce is relatively young. Most were hired after the air traffic controller strike in the 1980s, when President Ronald Reagan ordered that all striking controllers be fired. All right, I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Q. We are about to wrap up today's show, and I want to talk to you before closing today. I want to talk to you about air traffic controllers. Those controllers, they work at local towers, TRACONs, RTC centers, FSS, and the ADCCS. They work 40 hours a week, also some additional overtime hours. They usually earn between $46,000 to $87,000, depending on experience. The medium income is about $75,000 rather, as of 2018. They receive 13 to 28 days paid vacation and 13 days paid sick leave. They can retire as early as age 50 with 20 years active service, or at any age after 25 years active service. Air traffic control problems. In the United States, air traffic has increased dramatically since the federal government deregulated the airline industry in the 1970s. However, the construction of new airports and runways has not kept pace with the increase in air traffic. This has put excessive pressure, unfortunately, on the air traffic control system to handle the nearly 50,000 flights per day. Think about it, 50,000 flights per day, a number projected to increase in the near future. So to handle these flights and avoid delays and collisions, the FAA and NASA have developed modern software, upgraded existing host computers and voice communication systems, and instituted full-scale GPS capabilities to help air traffic controllers track and monitor and communicate with aircraft. So the FAA at this current moment is redesigning U.S. airspace to make more room for increased traffic. For example, the U.S. military has freed previously restricted airspace off the coast of North Carolina for use by commercial aircrafts. This effort should help ease traffic and minimize delays in the short term. However, what about the long term here, right? Increasing airport capacity by building new runways in airports is ultimately the way to handle the problem. Let's talk now about air crashes, right? You can't talk about air traffic control without talking about air crashes. In the event of an air crash or a runaway incursion, two planes on a collision course, then the National Transportation Safety Board, the NTSB, investigates. The NTSB team reconstructs the air traffic services given to the plane, examines radar tracking data, and studies transcripts of the controller-pilot conversations. We have devoted an entire show to the NTSB work. You might want to double check that, and so you can learn more about the topic. So let's just quickly recap today's conversation. So I was talking to you today about airspace and air traffic control, flight profiles, so pre-flight, departure, Unroot and descent, approach and landing. Talk about the careers and concerns. So what does it take to be an air traffic controller? I spoke about air traffic controllers in general, air traffic control problems, and air crashes. I will see you next time. But until then, remember, stay marvelous.